Alright guys, we're going to go over some redox problems. I'm going to start with an acidic one that's, I guess, mild, not one of the really hard ones, kind of an intermediate. And there's a lot of ways to do this, but this is just the simplest way that I've found to do it. Now I start by usually writing this if I think it might be applicable. It's just one of those helpful devices, mnemonic devices. Have no fear of ice cold beer. That's the way I remember it. And these are all the diatomics. Sometimes it's helpful, sometimes it's not. But either way, and this is another thing I'll write. And I'm sure you've probably heard of this. If not, you'll find out what it is. It's something I add on the end there. So anyway, first step that I learned is the charges. We're going to write the charges. So this is something not every professor is going to want, but it's useful to know either way, you know, whether or not you have to write it. So BR, it's the B in beer, a diatomic. So it's going to be BR2. That means it's going to have a 0 charge when it's on its own. So there we go, 0. Then we have the SO3. We know that the overall charge of SO3 is going to be a 2-. And for O, in general, it's going to be a 2-. So -2 times 3 is going to be -6 on the O. And that's how we can deduce the relative charge of the S. So in this case, it's going to be, if the overall charge is 2- of this molecule, together, this must be a +4. Because 4 minus 6 is going to be -2, which is the charge. Now we have the BR on its own. It's going to be a -1 plus the SO4. Again, we know the whole charge is going to be a -2, so we can get away with saying that 4 times -2 is going to be -8 on the O, and then this must be a +6. And that's going to be relevant when we try to determine which one's oxidized and which one's reduced later. Okay, so next, do the split. So on this side, I'm just gonna do it from right to left. So we're gonna start with the BR. BR2 yields BR minus. And then the other one, SO3, 2- yields SO4, 2-. Okay. So at this step, a lot of times you'll want to write which one's oxidized and which one's reduced. You can go by oil rig. Oxidized is loses or is losing. Reduced is gaining. And it's just a way to kind of explain the paradox of it all, because you're gaining an electron that's negatively charged. So it's just really confusing sometimes. I don't like to always write them here. You can, so this one goes from no charge to a negative charge, which probably means it gained an electron. So we can probably deduce that it's reduced. If I'm writing in pencil, I usually just put it in parentheses there, so I can give myself kind of a little note that I should double check it later. And I'll show you how I like to double check it later, which is pretty much like 99% foolproof. So obviously if this one's reduced, the other one's going to be oxidized. I don't always think through it both ways. Just if it's an exam or something and I'm rushing, sometimes it's not always necessary. So step 3, we're going to balance the non-O's and non-H's. So for the BR2 yields BR minus. That's really easy. There's 2 of them here. There's 1 of them here. Throw 2 there. Bam. Now SO3 2- yields SO4 2-. Notice there's a 3 here and a 4 here. Doesn't matter for this step though, because we're not even talking about O's. We're just talking about the non-O and H's. So the the sulfur, we have 1 here and 1 here, so we're good to go. On to step 4. Step 4 is going to be to balance the O's with H2O, water. So for again, I like to just rewrite them, but it's not always necessary. Just kind of keeps me organized, make sure I'm checking things. There's no O's, there's no H's, so we're good on that. Now for this one, we have the SO3 2 minus yields, scroll that up a little bit, SO4 2 minus, we have one additional oxygen on this side than this side. We're going to need an H2O over here. Now we have 3 plus 1 is 4, 4. So we're balanced on the oxygens. We're good to go down onto step 5. Balance the H's with hydrogen ions. So now we have Br2 goes over to Br, and there's no H's, so we're good to go. Now on this one we have H2O plus SO3 minus 2 minus, SO4 2 minus, and then we have the H2O, we have 2 H's over here, so throw 2H plus over here. So now we can just count it up real quick, 2 H's, 1 S, and then 3, 4, 4. Okay, so everything's balanced. Go on to step 6. So now we're going to balance the charges by throwing electrons in. E negative is how we write the electrons here. So let's see. So for Br2 we can see back, originally was, like I said, diatomic, so it had no charge. Yet on this side, the Br, we had 2 Br minus. So that has a negative charge, and that's easy. We just add one more electron over here, because the net charge of this side was 0, and then we added an electron to make it -1. This side it's -1. And, oh, I'm sorry, wait, that would actually be 2, my mistake. I think we would add 2 electrons, because there's 2 Br, yep. Another skinny 2. It's my curse. So, let's see here. Yep. So now we have the other equation there, SO3 2 minus yields SO4 2 minus plus 2H plus. This is one way to look at it. You can compare. This H2O is going to be a negative charge because -2 on the O and then +2 on the H. This has a -2, so 2 minus. This has a 2 plus over here and a 2 minus over here. So we know that's going to add up to be neutral. We're going to need to add 2 more electrons over here. Step 7 is to set the electrons equal. This is an easy one because this step is kind of not that relevant, because normally if we had like 3 electrons over here on the product side and like 4 over here on the reactant side, we would have to multiply each equation, which I'm going to probably show in the very next video in the sequence. But in this case we don't need to, because once we're going to combine the equations ultimately, we have 2 electrons here, 2 electrons here, we know that they're going to cancel out. So we can move right on to step 8. Combine and reduce. Again, I like to personally just look at it right to left and use the first equation that I wrote. So that will be the Br2 plus 2 electrons. Oops, I did it backwards. So H2O plus SO3 2 minus plus, so I'm just taking everything on this side and everything on this, everything on both equations that are on the reactant side and adding them together. And there's no funny business there, you just stick them next to each other, you don't have to combine things or anything on this step. Then on the product side we had the 2 Br minus, I believe from this equation, yep, and then we had plus SO4 2 minus plus 2H plus plus 2 electrons. And let's see, we can cancel out, the first thing we can do is cancel out the electrons, because 2 on each side, you can just get rid of those. And then I believe that is the last reduction you can do in this problem. If you had, say, 2 H plus on this side in addition to the H2O, which it would, I don't know if you would, but then you could reduce the H pluses. But yeah, we can just carry this down, and I'll write this properly this time. Plus H2O plus SO3, 2 minus, yields 2Br minus plus SO4, 2 minus, plus 2H plus. Now check. So check the elements, make sure there's the same amount on both sides, make sure that's balanced. So there's 2 Br, 2 Br. Let's see, 2 H's here, 2 H's here, 1 O, which will help with this because this is SO3 becomes SO4. It's good to go. So that's good. Now check the charges. So we have neutral charge, 2 minus, 2 minus, 2 minus. So a total of 4 minus, then 2 plus. So it reduces out, both sides are 2 minus, 2 minus. So that's good. So that means this is what they're looking for. This is the the final reaction, reduced as simply as it can be. Now another thing I like to do, this little part when I wrote underneath oil rig the directions, arrow, electron, electron, arrow, that's a way to separate them. So you can almost always, and I've never actually seen a single problem that didn't work out this way, if the electron is on the product side, which in this case, we added an electron here, I believe. Yep, so this is the SO3, and it's on the product side, oxidized. So we can, that's just one way to double check it. If you had to add a product to the reactant side, then it should be the equation that's reduced. And originally we thought the Br2 to the Br minus was the one that we had to add an electron to on the product side. I'm sorry, on the reactant side, which we did right here. So the reactant side, oxidized. So that's just an easy way to double check it, and you don't even have to know what it is at this step. You can come down, figure out where you're adding the electrons, and then go back. And usually you're going to have to add an electron somewhere, so then if one's reduced, you deduce that the other one is oxidized. So yeah, this is kind of an easier problem, and I'll probably go over some harder ones next. All right, I hope this helps someone.